My name is Mohammad Nafiul Haq Nafi, and I am from Group 15, Section 7. In this project, we focus on a major challenge in the modern Steam marketplace. In the modern times, people tend to play a lot of games, and developers want to make a game that usually they think as success. So, our work presents an end-to-end machine learning framework that predicts a game commercial success using pre-release metadata such as genre, categories, price, supported language, and others. We define the success as games that falls in the top 25% or crossing the 75% percentile. After cleaning the dataset and pre-processing, removing the leakage and doing some other methods on the language and encoding, we run the test by multiple classifiers, including gradient boosting, random forest, logistic regression, KNN, AdaBoost, and MLP neural network, along with hyperparameter tuning and threshold optimization. Overall, the results show the metadata, especially localization and pricing, can strongly predict which game can be highly successful and become high impact titles. So, the data we have collected is from the Steam market, where it is the largest platform for games. And in our data, there were a lot of samples and we removed a lot of the features as well because not all of them are quite useful to us. Some are descriptive, some are non-numerical, and some are irrelevant. So, with many releases, visibility becomes limited, and developers often struggle to understand early whether their design and marketing choice will lead to success, for which our project will help us show the best results and the success on which things they should focus to make their game as successful as possible. Thank you. My next teammate will talk about the literature review and the methodology that we have used.
Thank you, Nafi. Hello, everyone. My name is Nafi Imtiaz Fuad, and in this project, we will explore how you can predict the success of a video game before its release using only metadata available during the development phase. So, firstly, we will take a look at the related works. The first study, a data analysis of Steam game catalog, investigated how features like genre, price, and ratings affected popularity. The second study, a data-driven analysis of player personalities, analyzed almost 2 million Steam reviews to explore how personality traits like link to game genres. It revealed that player psychology, especially inferred from reviews, can predict engagement. Finally, the third paper, predicting the number of video games on Steam, combined static features with time series data to forecast concurrent player counts. It proved that models with temporal features can outperform static ones. So if we look at the um, data preprocessing, we can see that our dataset comprises of almost 95,000 Steam titles. Each game includes features like price, achievement, required age, and metascore, along with textual attributes like genres, tags, and developer information. Our target variable is successful was defined using the top 25% of games by recommendation count to categorize hit versus average titles. In data preprocessing, we carefully removed any columns that could cause data leakage, such as user scores or review counts. Missing values were imputed using medians, and categorical features like genres were encoded with multi-level binarizer to handle multiple genres. Now we will take at the models used. The 6 models that we implemented on our project were gradient boosting, random forest, AdaBoost, multilayer perceptron or MLP, KNN or K nearest neighbor, and finally logistic regression. So gradient boosting served as the primary model, which was optimized to maximize the F1 score. Then we'll take a look at the random forest. It was implemented as it was a robust system that could mitigate overfitting. Data boost was applied to enhance the classification accuracy for outlier or borderline cases by progressively reweighting misclassified instances. MLP or multi-layer perceptron is a feed forward of neural network. It enabled modeling of deep non-linear dependencies such as interactions between pricing strategy and thematic genre. Nearest neighbor tested the hypothesis that successful games are spatially proximal within the feature space, serving as proxy for similarity-driven success. And finally, we used logistic regression, which provided an interpretable baseline offering coefficient-based insight into each feature's directional impact on market performance.
Hey everyone, so in this part of this project, so I will discuss which of the features has more importance in our project and how we have refined those features, and the most important part, how we have increased the threshold and increased our accuracy in this project. Okay, so if we have to talk about this project, the first problem that we faced while imputing and encoding the data, the first problem was we end up having 231 features in total. So this is a huge number of features. So in all the model evaluation was in between 60 to 50 range. So we know that this is not a good score, right? So what we have to do then, so we have to use the classification reports so we can work on the cavity of the data so we can have better score. So what we did next, we used gradient boosting so that we can find out the most important features that we will need for this project. So then we rescale the data. Then we have to reduce the number of the data or columns because it will turn the entire process more difficult. So in this particular process, so even after doing so, we ended up having not that much of a good score. So then we have to take the help of hypertuning. Hyperparameter tuning is such a process in which we can run this system multiple times in a loop to find out which ones are the best threshold. So our threshold was around 30%. So we had to take the top 30% data with the refined parameters. So after refining those parameters, we end up having a better score. That better score is around 65%, and the recall score is around 68%, and the F1 score was a 65%, and the precision was also better than the previous one. So we are expecting, so according to our expectations, we had better results. So based on those data, further we reduce the number of columns furthermore, and we are end up having a slightly better score, which was the final decision that we had made. So this is the graph regarding those, and now I will analyze what are the findings. So basically the findings are, if we consider all the data, so these are the top 20 features that contributed the most, but according to that, we also had to find out which features had the most impact in terms of good prediction, and also find out the worst feature that will lead to having a worst outcome possible. So we have find out both in terms of that, and finally we have also see that from this price range, from 30 to 60 price range is the best outcome, then comes 20 to 30 price range, and finally if we are to see the confusion matrix, the confusion matrix also shows that we actually predicted the flop games in a more particular way, and then comes the actual hit that we predicted also right. Then comes the flop games that was turned into a false prediction. Then we used SHAP data to predict the positive or negative outcomes. So we had some limitations. The limitations basically are we had to work with a huge number of data, which was around 90,000 samples. So we had to refine those data. At the same time, we had a huge number of columns. We had a very cold start. Then we had to go through several tuning to have the better outcome. So as we believe, this is in our project, we worked on such thing that actually is not that available in the market, because most of the projects works on the outcome based on the game success, not is designed for the investor who might invest for a game and is predicting some sort of outcome from that. So we did that pre-launch phase for our project. Thank you very much.